Okay then guys, so I want to explain a little bit about special triangles and like kind of a little bit about why they're useful and also get into examples of in which you can use these special triangles. So special triangles, I'm not going to talk about this too much, just look at the picture. So over here we have the two different special triangles. So this one over here, just one of the things to note is like the differences between the two is that both of these angles over here are 45 degrees and both of these sides over here are of 1. And one way that I memorize, or yeah, basically memorize these special triangles, especially when I'm looking at this one, because I find that this one is the one that's harder to remember, is that I basically just remember that the 30-degree angle is right next to the square root of 3. So square root of 3, 3, 3, as in 30, right? So I just associate those 3's together because the sort of the angle that is 30 degrees is adjacent to the side that is square root of 3. So that's the way I kind of remember it. And I just know the other side is 1 and 2. If I were to remember, basically remember all these 3 numbers, then I would know to place 2 over here because the hypotenuse is the longest side. And if I just memorize these 3 numbers over here, so 1 and square root 2, obviously I know that square root 2 would be the biggest number out of those 3, so that would be the hypotenuse. So I'm just sharing like some quick tips about like how I kind of like memorize and think about these special triangles. So now let's just let's talk a little bit more about them. So like why do we use them? As I say over here, they're used to calculate the exact trig ratio. You could plug stuff into your calculator, as in like you could plug in like sine 30 into your calculator, right? Sine 30 degrees, but you'll actually just get like a huge decimal. You won't get an exact ratio. So the purpose of these special triangles is to give you an exact ratio for these special angles. And these special angles, as listed over here, are 45 degrees, 60 degrees, and 30 degrees, right? So I have a chart over here. So basically, I'm just going to go through this special triangle and kind of write down all of the ratios. Perhaps I'll cut the video here and I'll actually skip forward to when I've done all of them. Or actually, just to clarify, like as to the method in which I'm filling up this chart is basically just using SOHCAHTOA. So I'll just go to the first one on like while recording, I guess. So sine 30 degrees, okay? So that's this box over here. So sine 30. So we're using this special triangle over here because it has an angle of 30. So sine is opposite over hypotenuse. So opposite, that would be 1. And our hypotenuse would be 2. So it would just be 1 over 2. So that was real simple. So we do this for all of these. For the ones that are 30 and 60 degrees, we would be using this special triangle. And the ones that are 45 degrees, obviously we'll be using this triangle. So I'll just skip forward to when we have filled up this chart. Okay, then I filled up this chart. So I just placed, so just take a quick look at it. I'm just zooming in on it because I assume that I think when I'm recording the screen, it actually probably looks really small in comparison to the rest of the screen. So yeah, here it is. So I filled up the chart, and yeah, I just simply use SOHCAHTOA for each of these triangles. So I just went about that process. If you want, right now, you can kind of pause the video and you can look at all of these exact trig ratios and like see if they line up with the special triangle, or at least with how you interpret these special triangles. So yeah, I just put a quick like exclamation mark over here for this one because this is the trig ratio. But however, like one thing that you may realize at this point in your math learning journey is that basically we really don't like when we have a square root in the bottom of the fraction in the denominator. So we have to kind of cancel that out. So basically, what we can do is this. So we can multiply both the bottom and the top by square root 3, and then we can get square root 3 divided by 3. So yeah, just one thing to keep in mind. Also same thing for these ones even, right? So do the same thing. And I believe that you will get square root 2 over 2. So same thing for both of these. Yeah, cool. So that's basically these exact trig ratios for the special triangles. Now we kind of want to get into some examples of like questions that you could potentially get that would actually use these special triangles. I'm teaching you this concept, but I'm not actually showing you like how this would be used aside from just like, oh, memorizing this for your test. So let me show you some examples. So here's a quick example. So like for example, like you might have a question where you simply just have to know the trig ratios from heart. Basically, if you just know special triangles, then you could derive all of these without actually having to memorize this chart. So don't really worry about that. I remember that I used to just like focus in on the chart, but like basically like if you just know the special triangles, then you know the chart already, right? It just takes like a few extra seconds to kind of derive these ratios from the special triangle. So here's a question over here. This one's real simple. So if you just know tan 45, I'm just gonna pull this from over here, but you can kind of do the math yourself in your head when you kind of look at the special triangle over here. This one up here. So yeah, so this one would just be it would just be 1. So yeah, so simple. And now cosecant 60 degrees. So basically, I just include this in here to kind of bring up the point that since you already know these primary trig ratios, you actually already know the basically like the reciprocal ratios, right? All you have to do is just swap out this to or like change this to its reciprocal, right? So cosecant 60 degrees. Wow, that's terrible. That looks terrible, but yeah, cosecant 60 degrees would be equal to 2/3, right? So yeah, it's just the reciprocal of this. So yeah, and that's exactly how it works. So yeah, that's one example. I'll go over another one in a moment. Okay, then we have 2 examples over here. So the first I have sine, I don't know, I just put like alpha or whatever, equals to 1/2. So basically, I remember that one of my students would actually tell me that for part of like the trig unit or for some of the trig unit, they weren't allowed to use calculators. So like for this particular question, you might be looking at this and just be like, okay, I could just do this in my calculator, right? But in the case that you don't have the calculator, I just want to bring this up because basically like you can just use these trig ratios to kind of recognize that this angle would just be equal to 30 degrees. So yeah, of course, if you have a calculator always with you in class, then you could just do like this. But I'm just saying in the case that you don't have, like your teacher doesn't allow calculators for your test or something, because I know some teachers do that. So yeah, this one, I'm just gonna put it down as 30 degrees. So yeah. Okay, this question's a little bit weird, that's why I'm going over it. But the way that I would go about this question is first just recognize that, okay, this is the sort of the reciprocal of tan, right? So basically this cotangent theta is also equal to tan theta. Like 1/tan theta, so yeah. Like kind of like a reciprocal version of it. So yeah. Basically, I would just do that and go about the question from there. So I think from there shouldn't be too bad, but I will go through the math and see where I get to from there. So yeah. Then bring the tan to the other side. So yeah, then you could go about this question like that. Now this is actually the way that I like recommend going about this question because I think it's the kind of like the best. I think it's the best way to go about it, honestly. But just to finish this up, this will be 60 degrees. But I also want to kind of relate this back to our lesson over here. But I just want to also remind you that you can do math in many different ways, right? So basically, one thing that you could do is that you could recognize that, okay, you have 1/√3 over here. 1 divided by square root 3. That is one of our trig ratios, right? But the only difference here is that we're working with cotangent, right? We're not working with like tangent, right? But if we kind of refer back to our chart over here, we know that for this ratio, which is basically just square root 3, this is tan 60, right? So tan 60, tan 60 is equal to square root 3, or basically this, right? So we know that the reciprocal of that, the reciprocal of this would be equal, is basically just 1/square root 3. And the reciprocal of like tan 60 would basically just be cotangent 60 as well, right? So that's exactly what we have down here. So I actually feel like this is the kind of, although it may seem longer, I think it might be more difficult to actually manually think about these ratios and recognize it. However, I want to just bring up that you got both options. I would actually prefer going through this option, even though that this lesson's on special triangles, but this is applicable to like trig in general. So yeah, I hope you enjoyed this lesson, and I hope you got some value out of it.